In this video, I will talk about recursion, or it is also have another name, which is recursive formula. Recursive formula. This is very interesting topic. You will see that how this is and why this is interesting. First of all, let me just start from a story. Suppose that there is a builder who wants to make a ladder. Everything is ready. The ingredients is ready, so he has to build the ladder. So what do you think, what will he do first? The first thing he can do is to make a first ladder. Then after that, he makes another ladder based on the previous one. There should be some particular distance that he has to maintain, and he continue with that. So there should not be a ladder like that, steps, not ladder but the steps should not be like that. It has more distance in two steps and there is less distance in another steps. Okay, now what is the central idea of this story? The central idea is you start with some base step. Okay, you start with some base step and then you create uh, some next value based on the previous one. So this is called the recursive. This is called the recursive step. So now let me just write a mathematical way of recursive definition. We need some background why we need recursive formula. Why we need recursive formula, some background. You know that we have a formula n factorial. This n factorial is based on some base. Suppose we have 3 factorial, it means that 3 minus 1, 3 minus 2, 3 minus 3, something like that. Or maybe I can write this as, since you needed 3 factorial, can be written as 3 and 2 factorial. Then 2 factorial can be written as 2 and 1 factorial, and 1 factorial can be written as 3, 2, 1 and 0 factorial. So what is the base over here? The base is 0 factorial. So this is the basic base case of factorial. So factorial should start with some base step, which is 0 factorial. Similarly, if you know, for example, Fibonacci number has some bases as well. Fibonacci number has 2 basis step. The formula for Fibonacci number is Fn is equal to F at previous value, and then we also have 2 steps back, we have another past value. If I put n is equal to, for example, 3, then we have F3, F2, F1, and you see that we have to find the value for F2 and F1 so that we can get the value for F3. And in Fibonacci number, the base case is that you can have, for example, f of 1 is equal to 0, and f of 2, for example, is 1. That is the base case for Fibonacci number. Remember that the notation can change as well. For example, we can also write it as this value as if we start with n is equal to 2, then we should have f2, f1 plus f0. In that case, our base case should be defined in terms of 0 index and also in terms of 1 index, that is 1. So that's how we define the Fibonacci number, and you can see the recursive formula. Okay, so let me just start with some another example why we use recursive formula. Suppose that we have a sequence an, and that an is 2 raised to power n. And we should also define the value for n. It can start from 0, 1, 2, or it can start from 1, 2, 3, so on. It is up to you. You have to change the index accordingly to make a sequence out of that. So first of all, you want to generate a sequence n0. The first term will be 2 raised to power 0. Then we have 2 raised to power for n is equal to 1, 2 raised to power 1, n is equal to 2, 2 raised to power 2, so on. So you get 1, 2, 4, so on. This is the sequence generated from from this sequence formula. Now, if the same formula can be generated from another method, which is recursive formula, how you will do that? From recursive formula, how can we do that? Recursive formula, or through recursion, we want to find the formula for above sequence. Suppose we have an plus 1, an plus 1 is equal to 2an. And if we define n is equal to 0, 1, 2, so on, then you can see that when n is 0, we have 1 is equal to 2a0. So we need a value for a naught. Suitable value of a naught can be taken so that you can get the same formula as we found through the sequence formula. So a0 can be taken as a0 is equal to 1. So we can take a0 is equal to 1. So when a0 is equal to 1, we get 2, 1, which is 2. Similarly, when we have n is equal to 1, a2 is equal to 2a1, and a1 is 2, so we get 4. Then we have n is equal to 2, then a3, that will be equal to 2a2, so we have maybe a2 is 4, we get 8. So from that, we can get the sequence as well. A naught is 1, 1. A1 is 2, that is 2. A2 is 4, we have 4 over here. Then we have 8, so on. So you can see that we got the same sequence from the recursive formula, or recursion, you may say the recursion. So what is recursion? From out of all these examples, we can conclude, the conclusion is that we can write the new term in terms of the previous one. That is called recursion. It has many applications in computer science and in mathematics, infinite differences, so on and so forth. So you generate a new term from the previous one with suitable value for the seed. Okay. Okay. So now we just solve one example. You got the idea. You got the idea. The idea is that any sequence an can be written in terms of an plus 1 and some value of an. It can be sum, it can be multiplication, and so on and so forth. Example. Example. Suppose we have f of 0 is equal to 3, that is the seed value, and we have fn plus 1, the recursion formula that depends on the previous value to fn plus 3. Now, when n is equal to, and the question is find the value for f1, f2, so on. You can find many values from that. This is the question. So, solution. When n is equal to 1, we have f of 2 is equal to 2, f of 1. I should start from n0 since you can see that there is an error if I continue with that. So n is equal to, for example, 0. Then we have 0 plus 1 is 1, 2, f. Then we have 0 plus 3. Then we have the seed value, which is 3 plus 3, 6 plus 3, it is 9. Similarly, when we have n is equal to 1, n is equal to 1, f of 2, 2, f of 1 plus 3. F of 1 is 9 plus 3, and 18 plus 3, 21. Then we have n is equal to 2, f of 3, we get f of 3, 2, f of 2 plus 3. 2 f of 2 is 21, it is 21 plus 3. Then we have 42 plus 3, then we have 45. So that's how you generate a sequence from this simple recursion formula. Okay. Now, one thing that we want to understand is what is the role of seed in any recursion formula. So we want to learn that from some example. Suppose we have two sequences. One sequence is an, and we have one sequence an, and another one is bn. An sequence generate the values for a1, a2, so on, and bn generate the values for b1, b2, b3, so on. Now the question is that if you multiply the new value, if you multiply the past value in a, that is ak, 3ak minus 1, and the sequence has a recursive formula for b as well. Bk is equal to 3bk minus 1. Now the question is, either these two sequences will be same. This is our question, that these are same, or ak is equal to bk, since their product, the coefficient is the same in both cases. So now these will not be the same. The reason is that the seed value will be different in both cases. Suppose I take any seed value. Suppose I take the value for a1, that is the seed value. A1 is equal to 2 and b1 is equal to 1. Now I put the value for sequence a, k is equal to 2, a2 will be equal to 3, and 3 2 minus 1 is 1, so 3 2s are 6, so we get a2 is equal to 6. And we continue for the sequence a. K is equal to 3, a3, 3, a2, and a2 is 6, so we get 18. So sequence that we get out of the second out of a, for sequence a, it is 2, a2 is 6, a3 is 18, and so on. Now we talk about the second the sequence generated from that formula with seed b1. Suppose we have k is equal to 2, so b2 will be equal to 3b1, and this is 3. Similarly, when k is equal to 3, b3, that is b2, and b2 is, so we get 9, and you see that we have a formula 1, b2 is 3, b3 is 9. So you can see that one sequence generate a even number, or not even number, but 2 6 18, multiple of 2, and another one is uh, not multiple of 2, I'm sorry, 2 6 18, simply we say that. On the other hand, the sequence B generate the 1 3 9 and so on. So it means that this multiplication does not ensure that we get the same. The same multiplication does not ensure that we get the same sequence. It all depends on the seed we take, we decide for our sequence. Thank you for watching.